curvature scale along this curve. And then it looks like that the dimension or length of porcupine is going smoothly. So it's okay. The surface looks, we call, say, Faird's curve. But here something is not, sometimes it is going straight or some abrupt change here. But this case much worse, right? So here you can see that this is C0, C1, C2, and C infinite. C means the continuity, and continuity 0 means only position continuous, but there is no continuous curvature or slope. But C1 is continuous up to first derivative. So that slope is continuous, but curvature is not. So curvature continuity is coming with the second derivative, C2. So this is continuous curvature. But above them, you need to have more higher, right? So visual control. So why we need to have at least in engineering, we need to design up to C2 curve, C2 continuous curve, curvature continuous. Why? It is very important for hydrodynamics along the surface, and also the, how can I say, the looks great. The sun shining. When you see the car reflect reflect colors. Light is reflecting. If the surface not C2 curvature continuous, the reflection lighting is not pretty. Also, if you think about the surface of what is that? Turbine, steam turbine, gas turbine, the blade of the steam turbine, gas turbine, the surface of them one, that should be C2 surface. Otherwise, the hydrodynamics is not good. So that efficiency of the turbine is very low. That's why the engineers from the beginning is keen to develop or design a C2 surface of curves. The smoothness, visual control, unwanted flex point, oscillation. When you see the surface of the car, the sun shining, there is a small oscillations if the surface is not fair or C2. The flat curve section is also there, and curvature discontinuity in the composite curves. That is the reason why. And how can you generate curves? There are so many complex mathematical theory behind this. So I will not explain all of them, but some of them is shown here. Anyway, explicit and parametric representation of curves. There should be a properties, say something like a position, slope, and curvature, and continuity. And then there are mathematical equations, something like a cubic spline, Hermite spline, Bezier spline, B-spline, and nerves finally. Nerves is already seen. There are different methodologies of names of a person who developed these ideas in history. And finally, we need to generate a curve by using interpolation or approximation. So we'll see that. So Hermite spline, it is defined by the position and the position, the P0 and P2, that is the end of the curve section, and the position vector, and also the M is the slope of that curve at the position of P0, right? So by using those position and slope vector, you can create a Hermite spline. right? Then second one is Bezier spline. Bezier spline is coming using how can I say, the control point. So this is a linear Bezier spline, but in right hand bottom there is a cubic spline, and that gives you how many points. P is the control point, P0, P1, P2, P3, P4. So 5 control points. By using approximation of this control point, the red line is a real curve generated by this control point. In between, there is a second order, third order, and control point and Bezier curves. And that is the idea, but equation is complicated, right? Oh, it comes with more ideas. The curve is generated using computer, using control point, right? And if you move one of the control point, position of the control point, then the curve shape is changed. So by moving those control points, you can modify the shape of the curve. That is how the designer is doing the real design using control point. And there is a spline. Spline is a basis spline indication, basis function for the approximative spline. It looks like complicated, right? A iterative equation. I'll explain in detail. You can have another class for this details. But anyway, the curve does not pass through the control point. As you see before, control point and curve are different. It looks like a curve is approximating somehow weighted sum of somehow the control point. And the curve does not pass through the control point, excepting the starting point and end point. In the middle, those are not same, right? Not pass through. So, and then each interval of curve, the equation has averaging, approximating is different. That gives you different shape of the curve. Now we have a nerves video.
In this lesson, we will learn about NURBS, objects, and modeling. NURBS stands for Non-Uniform Rational B-Splines. NURBS are useful for very smooth objects or when you need an exact surface. A NURBS object always has 4 sides and is made of mathematically created curves which are defined by control points. An individual control point does not show where that surface will be, but it is averaged with the surrounding points to create a curved surface. This means we cannot directly edit the surface. If we pull a control point, the surface will only move a little bit because we are averaging the change. To create complex objects using NURBS, we have to create many individual NURBS objects, often called patches. A common issue when working with NURBS is visible seams or breaks in the otherwise smooth surface between patches. But with care and correct workflows, we are able to hide the seams between patches so that this multi-patch object looks like a single surface. These difficulties mean that NURBS are rarely used in the computer graphics world, but it is often used in engineering and product design because of the very precise nature of NURBS. If you need to create a very smooth object or mathematically exact surface, try using NURBS.
Okay. Question? No question? Let's go on to then. Okay, there's a computer software called computer-aided ship design. And they use computer to draw or design conventional hull form modeling. Conventional means it is not fancy, right? Conventional. And ICAS, I brought you through the Kakao, the conference. They discuss presentation of such a KAIST softwares in that conference. And parametric modeling of complex shapes. So in left-hand side up, there is an AP and FP. So it's a lengthwise curve of sectional area curve, something like that. And then that gives you right-hand side up, there's each sectional curves of the ship. The body plan looks like a body plan. And then finally, we arrive at the right-hand side, the bottom, there is a ship-like surfaces or series of curves along the length of the ship. That is the way how the computer is working. Also in human is doing similarly. And then finally, we arrive at surfaces from the curves of lines. So parametric modeling of complex shape, and each verb of special corners can be highlighted with different colors for some reasons of designing. And then the complex form variation, they can modify a portion of the ship surface by using control point, by moving control point. So design changes, small modifications, especially near the bulb front part of the ship. So it's easy using our computer software. And Tribon is a very famous software for ship design, CAD system, coming from originally from Sweden. But now it is merged into another company called Aviva. Aviva is a company from England. So that now the new name is Aviva Marine, and most of the Korean shipbuilding companies, big shipbuilding companies, use Aviva Marine, probably except Samsung. Samsung use Intergraph, another computer-aided ship design software company. Okay. So they use sectional area, sectional curves, and then in longitudinal way, the outline, shear curve at the front and in the middle, and also at the backyard, and arrive at this curves patches, curve patches of the ship. And then they can use other numbers and parameters to arrive at, oh, this is a calculation for turning circle. So the driving car, you need to have a handling of curve making, corner making. So it's same as the ship. The diameter of this circular one of the ship is this small piece is a ship. Ship is moving from this way and this way, and this is ship. So when it's a turning of ships, it depending on the ship size and speed and control point, the diameter is fixed for the ship. So this diameter, if it is smaller, then we say maneuverability is good. It is big, then it is not good. If you think about, say, old days, the turning circle is important for battleships, Navy ships. When they shoot a torpedo, or you can think about the old days of airplane fighters in World War I. The chasing enemy fighter jet is important. So turning circle is very important at the time. Size of turning circle. And then calculation of, say, some, this is looks like, what is this? Half radius of the ship. Right. So size of the, or distance, half radius of the each station, and height. And then CATIA is another software. This is popular in aerospace industry and also automotive industry. Not so popular in shipbuilding industry, but they also can design a ship surface. So this is CATIA used for design a ship surface. And easier, it is another software. It's coming from University of Korea, the Seoul National University. There's a small company brought up, and they developed their own software. And this is screen of that software called EasyHer. And easier, the same software. They can use different data coming from different softwares, and then can use connect to Tribon. Probably IntelliShip is coming from Intergraph, AutoCAD, popular one. Probably CATIA should be somewhere here. And now NAPA is coming from Finland, SECOB and ShipFlow. So anyway, the data interface between different softwares is also, how can I move design coming from Tribon to easier, or from AutoCAD or to another software? So using this kind of formats, standard formats. Oh, okay. Finishing, good. Good to finish earlier than schedule. Questions?
Professor, I have a question in
Sure.
page 13.
Page 13.
And I can't get the left upside graph. What is that graph?
Share again. Right? This is part 13. This one.
Yeah,
right?
yeah.
So what is your question again?
Left upside graph.
Right?
I don't know what is that graph.
That graph is looks like a sectional area curve. So AP, it shows the AP and FP, right? AP means after part of the ship, stern part. FP is front part. And at the here, this is the position where the red line. So at this section, you need to have a special curved surface of the ship. And in body plan, right hand up, this red line is coming from this area. And then this one is copied into left hand side, gives you this curve at the bottom of the right. So each curve, a sectional curve is like sectional curve generated by using this kind of way, starting from sectional area curve and setting the station, each station, 20, probably usually 20 station. And each station you draw the curve of the ship, half radius, and then this is mirroring to the left hand side and arrive at this one. So it's along the axis or longitudinal length, and shape is doubling, then we can arrive at this kind of series of curves. And finally, they filling up between the curves arrive at this surface. That is the main idea, but the real mathematics behind it is more complicated. But
Thank you.
when I was a student, as a class, we draw such a surface, not surface, but up to the curve of this one. That was our work in that time. Starting from, usually we start from this offset table. Where is offset table? That's shown here. The other table. Offset table looks like this one. Offset table. Starting from this offset table, then we should arrive at the Tom project was to draw these line drawings. Line drawing is not here. Line drawing is this one. This one. So as a student, I should submit this final drawing starting from offset table like this. So how can you do that? Right? That is your homework. It can be a homework. It's not simple, right? But anyway, that is the way how we can do developing lines drawing and surface. But, so you need to have many more questions to me because it's not simple. I'm trying to explain them, but time is short. So that's why I just jumping around the ideas. So you need to raise more questions to me. All right. That's okay. Then we need to have a next time. We should have a presentation of yourselves. Tom project, right? So on Thursday we will have a 2-team presentation, project proposal presentation. Because we have only 2 teams, you can have more time to presentation. But at least you have say 5 minutes or 10 minutes presentation. And then we will have a discussion. And the grading can be done by myself and Jihu, the TA. Two person will grade. And also because we are unbalanced numbers, one team has 3 members, one team has 2 members, we will consider that differences to be fair, more fair. Okay. All right. Midterm exam Tom project uploaded to the website. Yeah, I can do that, but I may maybe missing my memorize. I've tried to, but you can try the previous and previous years. There should be some midterm exam already uploaded, and also Tom project. Not all of them, but because there are at least 3 or 4 years of websites, then you can try. Jihu, can you check whether which year there is a midterm exam is uploaded and which year the Tom project is uploaded, and let them know, student knows about this.
Okay.
Other years, where is the link? Probably Jihu can find out and show the link. One by one, probably. Because the lecture note has all the, by modifying the number of year, you can probably get to this one, at least 3 or 4 years. That is my guess. Otherwise, let me know again. I can find out myself. Okay? If you first try, TA will try to do, and you can try If there is a problems, then let me know. Okay.
Professor, by changing the number on the web page address, I can only access to 2020.
There's no 19.
Yeah, so before 2020, the address is completely different, I think.
Find out. This is coming from 19. But anyway, I upload on the chatting box link to the 19 website. In that way. Okay, also probably in my website probably shows you. Class and lectures.
I found the one for 2017.
2017?
Yeah, I've posted it on the chat box.
Where's the lecture? Yeah, here is so many links here. You can find out. Yeah. Okay, try this and then let me know. All right, see you on Thursday. I can upload this one again into Kakao again.
Thank you.
Bye now.